Well, thank you for purchasing this second lesson on basic trigonometry. We're going to use it to show you how trigonometry can help you find angles in triangles. Okay, the first thing you need to know is that you need to have the lengths of two sides in a right angle triangle, and if you know that, then you can find the size of all the angles. And of course, if it's a right angle triangle, one of the angles must be 90 degrees. But nonetheless, if you know the lengths of two sides, you can find the sizes of the other angles. But before you can do this, you need to know how to use some very special buttons on your calculator. And these buttons, there we are. These buttons are called the inverse sine, the inverse cosine, and the inverse tangent buttons. And the way they're written like this, with a little -1 in the top right hand corner, little -1 there. This is the inverse sine, the inverse cosine, the inverse tan buttons. Now these buttons are usually found using the shift function, and if you look above the sine buttons and the cosine buttons and above the tan button, you'll probably find in a different coloured ink these inverse tan functions. And what they do is they really reverse the process of finding sine, cosine and tan, so that you can find angles. But these are the buttons you need to know how to use to find the angles. Okay, let's see how these work in practice by doing some examples. Okay, in the following triangle, find the size of the angle ABC. Well, the angle ABC is ABC, and this little hat over the B tells you that it is the angle at the corner B. Sometimes they have this little hat and sometimes they don't, but the middle letter of a triple letters like that is usually the corner where the angle is. But anyway, you've been asked in this question to find the angle at that corner. First thing to look for is a right angle. Well, there it is. So we're dealing with a right angle triangle, so we can use trigonometry. Okay, let's see how we do it. First thing is we need to say, well, what's the relationship of this side, the length of which we know, to that angle? What's the relationship of this side, the length of which we know, to that angle? And we do it like this. Okay, we say that the 5 centimeter is the length of the side which is adjacent to the angle ABC. Now you will know from our first lesson that adjacent really means alongside, so it's that one alongside the angle. And the 23 centimeters is the side opposite to the angle ABC. Well, there is the side opposite the angle. Now, adjacent, opposite. There's only one trigonometric ratio that uses the lengths of the adjacent and the opposite side. Which one is it? Okay, good. It's the tangent. Only tangent uses the lengths of these two sides. So we can immediately do this. We can say the tangent of ABC, in other words the tan of that angle there, is the opposite over adjacent, which is 23 divided by 5, which works out as 4.6. Now, this 4.6 is the ratio of these two sides. How do we get to the angle that gives this ratio? Well, we use those special buttons, and there it is. What we now write is that if the tan ABC is 4.6, the angle ABC must be equal to the inverse tan of 4.6, and when you do that on your calculator you will get this long decimal, but it is actually in degrees. You will have to make sure, of course, that when you switch your calculator on that it is in degree mode. Usually by default it is set in to go on in degree mode, but just check that it does go on in degree mode. Anyway, this 77.73522 degrees, this is the angle whose tan is 4.6. Okay, so just think of it like that. This is the angle, the tan of which is 4.6. And if you round that up to the nearest, to the first decimal place, you get 77.7 degrees for the angle. Alright, now let's do another example. This time we're going to be using some bearings by way of revision a little bit. Don't worry, I will show you exactly how to do these bearings. I'm going to get that in the middle. There we go. I'll read it out first. The reason I'm going to read it out first without a diagram is because really it is very good practice if from reading things out like this you can actually construct a diagram of the situation. Alright, let's see. A lighthouse L is 63.4 kilometers due north of a ship S. A tanker T is due west of the lighthouse and at a distance of 96.7 kilometers from the ship. You've got to calculate the bearing of the tanker from the ship. Okay, well, you may ask yourself, what's all this got to do with trigonometry? Well, once you've constructed the diagram, you should see exactly what it's got to do with trigonometry. Let me put the diagram down first like that, and then I'll read out the question again. I can't fit it on the screen at the same time as the diagram, so I'll read it out and I'll point to what's on the diagram. Okay, it says a lighthouse L is 63.4 kilometers due north of a ship S. So this is a north line. Okay, a tanker T is due west of the lighthouse, and this tanker is at a distance 96.7 kilometers from the ship. So the length of that line is that, 96.7 kilometers. And they want you to find the bearing of the tanker from the ship. So in other words, if you want to find the bearing of the tanker from the ship, you are standing at the ship, and the bearing, which as you should know, is always taken from the north line going clockwise. So the bearing, the angle you have to find is this one here, that one there, this reflex angle. Well, let's see how we can use trigonometry to do this. Well, because they tell you that the lighthouse is due north from the ship and that the tanker is due west from the lighthouse, that is in disguise telling you that this is a right angle. If that's a right angle, then you have a right angle triangle. If you have a right angle triangle and you know the lengths of two sides, you can find an angle, which is exactly what we're going to do. If we can find this angle in here, then all we need to do to find the bearing is to take this angle away from 360 degrees, and we will have found the angle, or sorry, the bearing of the tanker from the ship. Okay, so we need to find out what's the relationship of this side to this angle, what's the relationship of that side to this angle, and we can do it like this. Okay, the 63.4 kilometers is the side adjacent to the angle at S, and the 96.7 kilometers is the length of the hypotenuse. Well, now you've got adjacent and hypotenuse. We know the length of the adjacent side to the angle, we know the length of the hypotenuse. Which trigonometric ratio uses only adjacent and hypotenuse? Which one is it? Correct. It's the cosine. There we have it. So, only cosine uses the lengths of these two sides. So we can write immediately that the cosine of the angle at S, that's that's that angle there, this pinky one, is equal to the adjacent divided by the hypotenuse. And I can show you that like that. Let's cover that up. The adjacent is 63.4 kilometers and the hypotenuse is 96.7 kilometers. When you divide that using your calculator, you will get this long decimal here. This is the ratio, okay, of these two numbers. We have to find the actual angle whose cosine is this. So we have to use the inverse cosine, which is this one here. So we say that the angle at S is equal to the inverse cosine of that long decimal, which you would use your calculator for, and it will give you 49.03 degrees. Think of it like this. This is the angle whose cosine is this long decimal. Okay? So, we found the angle at S. We can now find the actual bearing of the tanker from the ship. We've got to take away the 49.03 from 360 degrees, and we will get this angle here, or to the nearest degree, 311 degrees. Okay, now that was using a bit of bearings together with trigonometry. Here's another example, and this time we're dealing with the floor plan of a rectangular warehouse PQRS as shown below. Rectangular immediately should tell you that these four corners are all 90 degrees. Okay, important information which is in the question. You should not overlook things like that. Let's see what they want us to find. Okay, if I can get that. There we are. Okay, now it says a cable is stretched from corner S to corner Q. So it must be stretched across like that in a diagonal, and is measured to be 271.6 meters. The width of the warehouse is 83.9 meters. This must be the 83.9 meters, the width. Find the angle between the cable and the side SR. Well, there's the side SR, and the cable runs from S to Q, so clearly what they want you to find is this angle there. Okay? We know that length, we know this length, we know that that's a right angle in there, so it's a straightforward piece of trigonometry. We have to say what's the relationship of this side to that angle, what's the relationship of that length to this angle, and when you do that you will get the following. If I can straighten these diagrams up. Whoops, there we go. Yeah. The 83.9 meters is the side opposite to the angle. There it is. That is opposite the angle. And the 271.6 is the length of the hypotenuse. Okay? The longest side. And only sine uses the lengths of these two sides. So immediately we can say that the sine of the angle QSR is opposite over hypotenuse, and we have to divide 83.9 by 271.6. This gives you the long decimal there. We need to find the angle that gives this long decimal. So we have to use the inverse sine button, and there it is. We say now that the angle QSR, that was the angle at the corner S, is the inverse of this long decimal here, the inverse sine of that long decimal, and you get this angle here, which you can round up to the nearest degree as 18 degrees there. And just think of this thing here, this angle here. This is the angle whose sine is this long decimal there. So we've used the inverse sine button. So we've given examples now of using the inverse tan button, the inverse cosine, and the inverse sine buttons. Okay, let's see how we can use these in more lifelike situations. And to do that, I want to go on to talking about angles of elevation and angles of depression. Now, the angle of elevation, this is an angle measured upwards from a horizontal line. Now, usually the horizontal line is horizontal ground or sea level. Okay, so if you had a situation like this dotted line here is the horizontal ground or the sea level, and an angle of elevation is that angle there. Okay, the angle of depression is the other way round. Okay, this is an angle measured downwards from a horizontal line. Now that horizontal line, you're usually on a cliff top or a hilltop or the top of a tower, something like that. And there's the diagram for the angle of depression. There's the horizontal line, there's somebody or something on top of a cliff, okay, and the angle of depression is that angle in there. That's the angle of depression. Okay, one thing to notice about the angle of depression and angle of elevation is that together they form a pair of Z angles. This would be an angle of depression and this would be an angle of elevation, assuming that the person up here is looking down to the same point where this person is looking up to that person there. Okay? Now, okay, let's do an example. A girl is flying a kite with a string of length 62 meters. If the string is straight and the angle of elevation of the kite is 70, calculate the height of the kite. Okay, now you'll notice that if the string is a length 62, this is not a height, the vertical height above the ground. This is just the length of the string. It says calculate the height of the kite. You may ignore the height of the girl. Okay, so the situation must look something like that. There's the horizontal ground. Okay, there's the length of the kite string. There's the kite here. And so they want to know the height. The height above horizontal ground must be this vertical height there. Okay, so we're going to construct the diagram for this situation. The diagram using a right angle triangle. Okay, there's the right angle triangle. I've called the vertical height of the kite H, and here is the angle of elevation 70 degrees, and there's the length of the kite string 62 meters. Well, now, how do we use trigonometry to find H? Well, again, we have to work out what's the relationship of this side to that angle and this side to this angle. Okay, and you could do it like this. H is the length of the side which is opposite the angle 70 degrees. See, that side there is opposite this angle, and 62 meters is the length of the hypotenuse. The hypotenuse is always opposite the right angle or the longest side. This is the hypotenuse. So we know the length of the opposite side to the angle. We know the length of the hypotenuse. Now, which trigonometric ratio, sine, cosine or tan, only uses the opposite and hypotenuse, the lengths of these two? Well, which one is it? Very good. It's sine. Only sine uses the lengths of these two sides. So we form a little equation using this knowledge. We can say, whoops, there we are, it's better. I'll get that down here. Okay. We can say that the sine of 70 degrees is opposite divided by hypotenuse. Well, the opposite is h. We called it h. We could have called it any letter, but I called it h for height. Okay, divided by 62. Well, when we take the sine of 70 degrees, we will get a long decimal. So we end up with this equation. This long decimal is the sine of 70 degrees, and this long decimal must equal h divided by 62. Now I'm going to use a method called cross multiplication, which is a little bit out of favour, but it is quite a neat shortcut. The way I should get rid of this 62 in the it's this 62. I was pointing at the wrong 62. The way I should get rid of this 62 here is to actually multiply both sides by 62 and then cancel that 62 with the 62 I put up here. But that is a little bit long-winded. It is the correct method, but this method of cross multiplication I'm going to show you is just as effective, if somewhat less fashionable. Alright, but it does work. So cross multiplication does this. I'm going to take the 62, which is on the bottom, there it is, and I'm going to multiply it up there, so that my next line reads like that. There's the multiply sign. It's in red. It's a little bit dim on the image here, but it is there. That's a multiply sign. There's the long decimal for the sine of 70 degrees. It's being multiplied by 62, and it's giving the answer of 58.26094249. It's long decimal here, which if you round it off to one decimal place is 58.3 meters, which is what h equals. In other words, the vertical height of the kite above the ground is this value here, 58.3 meters. Okay, let's do another example and we'll see what we can learn from this one. This is example 2, and it reads like this. A ship is anchored 2.56 kilometers from the base of a vertical cliff. The angle of depression from the top of the cliff to the ship is measured to be 22.6 degrees. What is the height of the cliff in meters? Okay, well, let's make a little diagram. There we have it there. If I can get both the question and the diagram on, there we are. There's the ship anchored 2.56 kilometers from the base of a vertical cliff. So this distance must be 2.56 kilometers. There's the cliff, okay, and there's the angle of depression. So there it is, down to the ship from the edge of the cliff up there, 22.6 degrees. What is the height of the cliff in meters? So we will need to find this height here. Okay, let's see where our right angle triangle is and what piece of trigonometry we need to use. Here we go. Let's put it all up there. No, I don't want to show you that just yet. Alright, I can get rid of that. So clearly the right angle triangle looks like that. There's the height of the cliff, and I've called that height of the cliff C. Okay, there's the angle of depression, and there's an angle of elevation. Remember what I said about the Z angles? Well, this is the same angle here, 22.6. The ship is here, and the base of the cliff is there, and this is 2.56 kilometers. So we know the length of that side. We want to find this height here of the cliff, and we know this angle here. So again, we have to work out the relationship of this side to this angle and the relationship of that side to this angle. Okay, we do it like this. I won't show you all the answers just yet. C that's that one there, is the side opposite the angle 22.6 degrees. Okay, there's the length there, C is opposite to that angle, and 2.5 kilometers is the length of the side which is adjacent to this angle. It's alongside this angle. Okay, now which trigonometric ratio only uses the lengths of the opposite and the adjacent sides? Which one is it? Yes, you're right, it's the tangent. Okay, so only tangent uses the lengths of these two sides. So immediately we can write that the tangent of 22.6 is equal to opposite over adjacent, and if we do that we get this little equation here. Okay, the tan of 22.6 is opposite over adjacent. The opposite side is the one we want to find. We've called it C, the height of the cliff. Again, I'm going to do a little bit of cross multiplication. This 2.56 I'm going to multiply up to the long decimal. This long decimal has come from using my calculator and putting in, finding the tan of 22.6 degrees. Finding the tan of 22.6 degrees gives you this long decimal here. I then have to cross multiply this 2.56 up like that, giving me this equation to work out. It's 2.56 times all of that long decimal equals C. If I do that, I get this answer here. Don't forget that this is in kilometers, so I've turned it round and I've expressed it in meters. Okay, C is 1.0656 kilometers, or to the nearest meter it's 1066 meters, which is pretty high for a cliff, but nonetheless the trigonometry is correct and this is the correct answer. Now finally I'm going to look at a more complicated situation, physical situation. When I say more complicated, it's only more complicated because there are two right angle triangles in the question, sort of hidden in the question. And here it is, here's the question. Again, I've not put in the question the diagram because I was wondering whether we could figure out what the diagram would look like from the words. I will put the diagram up in a second, but it's very good practice mentally if you can figure out from the description what the diagram should be. Okay, let's see what it says. A guard stands on top of a 55-meter watchtower. He looks out and spots two escaped prisoners hiding. If the angles of depression of the two prisoners are 10 degrees and 23 degrees, you've got to find the distance between them. So find the distance between the prisoners. Okay, well, what would that look like as a diagram? Okay, well, it's probably pretty easy really. It would look something like this. There's the watchtower, okay, and there's the first angle of depression, 10 degrees, so one prisoner is hiding there, and the other angle of depression is 23 degrees, so the other prisoner is hiding there. So we have one prisoner here and one prisoner there, and we've got to find the distance between the prisoners. Okay, so the actual distance we have to find is this little distance there. Okay, let's see how we have the two right angle triangles, one on top of each other. Well, you've probably guessed what it looks like by now. There it is. Okay, remember the Z angle thing I said? This must be 10 degrees because the angle of depression from the tower is 10 for there, and this must be 23 degrees because the angle of depression for the second prisoner is 23 degrees up there. So the situation we have looks like this. There's the height of the tower, 55 meters, and we are being asked to find the distance between the two prisoners. In other words, this red line here, we need to find that distance. Okay, let's see if I can get that together with this. Okay, the distance shown by the red line must be the distance between the two prisoners. Okay, I've just said that. So if we know the two bottom lengths of each triangle, we can just take them away and get the distance between the prisoners. Yes, so you've got one right angle triangle like this, and the other right angle triangle, is this one there. So you do have two right angle triangles sitting on top of each other. One there, and the other one like that. So if you can use trigonometry to find the length of this length here, and then you use trigonometry to find the length from there to there, all you need to do then is take the smaller length away from the larger length, and you will have found the distance between the two prisoners. Okay? So the best way to do this is to treat each triangle separately, which is exactly what I'm going to do. I'm going first of all to look at the 23-degree right angle triangle, and then I'm going to look at the 10-degree right angle triangle. Okay, so let's see how we do this. There is the 23-degree right angle triangle. Now, I've called this position here, this length here, P1. You can hardly see the little 1 by the P there, but it is P1. And it just stands for prisoner 1, or the first prisoner. Okay? So I need to find that length there. There's my 23 degrees, there's my 55 meters for the height of the tower. I have to work out the relationship of this side to that angle and this side to that angle. Well, what have we got? 55 meters is the side opposite the angle 23. Well, is that true? Yes, it is. Look, it's opposite the angle. And P1, this length, is the side adjacent to the angle 23 degrees. Well, which trigonometric ratio uses only opposite and adjacent? Well, which one is it? Very good. It's tangent. Okay, so only tangent uses the lengths of these two sides. And so we can immediately write the following, that I can get rid of this now. We can say that the tangent of 23 degrees is the length of the opposite side divided by the length of the adjacent side. Well, that is 55 divided by P1. It's this P1 we want to find. Okay, so the equation we've got to solve is this one. There's the equation. We need to find P1. Now this is where cross multiplication comes in very handy, because it is a very quick method. I would have to rewrite this equation to get P1, to make P1 the subject of the equation. And if I did it the way the textbook says you should do it, it would involve a lot of multiplying both sides by P1 and then dividing both sides by this tan 23. But if you use cross multiplication, you can do this. You can multiply the P1 up to the top over on this left hand side, and you can take what's on the top of this left hand side down underneath the 55. Okay, it's called cross multiplication. So the equation can immediately be rewritten using P1 as its subject as 55 divided by the tan of 23 degrees. Alright, if you're unsure about this, use the method that your teacher has probably taught you, and you'll see that you will eventually get to this little equation here with P1 as your subject. Alright, but if you can get your heads around this little bit of cross multiplication, it will save you a lot of time. Alright, now how do we solve this? Well, it's very straightforward now. We now have to find the tan of 23 degrees using our calculator, and that will give us this long decimal here, and we divide that long decimal into 55. We get that long decimal here, and when we round it to the nearest, or the one decimal place, we will get 129.6 meters. In other words, the first prisoner, if I can put that there we are, the first prisoner there is 129.6 meters away from the base of the tower. So we found that length there. Okay, now let's do the same thing using the 10 degree right angle. Okay, there we are. I've written down here that the length from where the second prisoner is to the base of the tower, I've called it P2. You can't see that little 2 there, it's so tiny, but it does say P2, or the second prisoner. Well, what have we got? We've got a 10 degree angle here, and we've got a 55 meter high tower, and we need to find this length P2 here. So again, find the relationships of this side to this angle and that side to this angle. And again, no surprises, 55 meters is the side opposite to the angle, and P2 is the side adjacent to the angle. Opposite and adjacent, yes, it's tan again. The tan of 10 is 55 over P2, so it's 55 divided by P2, and again we can use a very good piece of cross multiplication. Here it is, 55 divided by P2. We can multiply the P2 up to the top over here, and we can multiply this tan 10 degrees down to the bottom here, and the equation we have to solve is that one there. P2 is equal to 55 divided by that long decimal. This long decimal is what your calculator will give you for the tan of 10 degrees. Okay? When you divide that into that, you will get 311.920501, and which is to the nearest meter, or sorry, to the nearest to one decimal place, is 311.9 meters to one decimal place. Okay, so we've now got this length from there to there, and that is 311.9 meters from there to there. And so to get the distance between the two prisoners, which is P2 take away P1, the smaller distance is being taken away from the larger distance, and we end up at 182.3 meters. Okay, well, thank you very much for your attention, and I hope that that certainly helped you with your trigonometry. Don't forget that there are 2 more lessons for the higher people on advanced trigonometry, and they should be ready fairly soon. Okay, thank you very much.